I only see like the chest tube.
Okay, yeah, that's it.
You think yes or
That's it. Let me see if I can. No, okay, I gotta scroll down. So the chest tube, it reestablishes negative pressure in the pleural space. That's what we were talking about. That negative pressure is like the vacuum suctioning. So a good example would be, well, one, a vacuum, and two, whenever we did the blood draws in lab, the kind of suction that it creates, that's negative pressure, and positive pressure is the exact opposite. It's like a hair blow dryer. We're just pushing all that air in. So the reason we want negative pressure is because that space in between the lung and the actual chest wall, we need the negative pressure. We need the sucking to keep the lungs inflated, because they won't inflate otherwise. They don't have any muscles to keep them inflated, so we have to like suck them up, like sucking up your cheeks, to keep them from collapsing and to get them to expand. Okay. As the chest expands, that negative pressure pulls the lungs outward, preventing collapse. The pleural space is the space in between the lungs and the chest wall. That's the space we're talking about. So there's 3 types of problems that require a chest tube specifically. In a pneumothorax, it's the chest tube that removes air. By the way, I'm recording this so Anadelia can also see it. That's why I'm teaching it like a class. Sorry, I just wanted to let you know. In a pneumothorax, we're removing air. That's at the top because air isn't as heavy as blood. Blood is going to sink to the bottom. A hemothorax is the blood, which is going to be at the bottom. And a pneumothorax is both air and blood. So a question, a chest tube is placed in for a patient with a hemothorax. What would the RN report to the physician? A chest tube is not bubbling. B, a chest tube drains 800 milliliters for the first 10 hours. C, chest tube is not draining. D, chest tube is intermittently bubbling. And the answer is, what is the chest tube not supposed to do? The chest tube is supposed to drain instead of bubbling, so therefore C is the right answer. Why? Because we put in a chest tube for blood, and if we saw that there was no blood draining from the chest tube, that would be concerning, right? Because we need it to drain. Yeah. We need to check that. The second question is the opposite. A chest tube is placed for a patient with a pneumothorax. What would the nurse report to the physician? The chest tube is not bubbling. The chest tube drains 800 milliliters in the first 10 hours. The chest tube is not draining, or the chest tube is intermittently bubbling. So with a pneumothorax, the bubbling is expected, and I'll get to that. I'll explain that in a moment. So what do we not want? We don't want them to be bleeding. We don't want them to have 800 milliliters of collection in 10 hours, because they're not supposed to be bleeding. We didn't put that tube in because they were bleeding. We put their tube in because they had air in them. So that's something that definitely needs to be checked. So the location depends on what kind of, we were just talking about this, the location of the tube depends on what we're pulling out. If we're pulling out air, we're going to expect bubbling. So at A for apical, for air. So apical, we're removing air. Bacillar, we're removing blood. So B for blood. The apical is your pneumothorax. We're going to be expecting bubbling because we're going to be suctioning that air out, kind of like when you suction from a straw. This one's full, but like when you suction from a straw when your drink is almost finished, we're pulling out that air. When it's not bubbling, that's bad because it means we're not pulling out any air. So an example of a bad sign would be, again, if we were draining blood from an apical area where we were supposed to be draining air. Same opposite idea for the bacillar. If we were draining blood for a hemothorax and it wasn't it wasn't draining blood at all, we would be concerned. So the expected amount is 200 milliliters per hour, within the first hour, 200 milliliters within the first hour is considered normal. So if it were more than 200 milliliters, I think we would be scared shitless because that's a whole lot of blood to be losing from your chest. Trick question, where would you place a chest tube for a post-op right pneumonectomy? So the trick here is that a pneumonectomy is the removal of a lung, so they don't actually need a chest tube, but they will need a chest tube for a lobectomy, which is only a part of the lung that was removed. I doubt they'll ask you that. He just put that in one of his lectures. So how do chest drains actually work? So he mentions the Jackson Pratt, that those are different. These pictures are, I drew one of them and you can tell which one I drew because it looks really fucking bad. But these are chest tubes. And something he doesn't explain, I don't think as great, is which does which. So I'm going to focus here on my picture because I just feel like it makes the most sense. We're operating on the principles of negative pressure, which is the air going out, right? We're sucking that air out. So if we start at the patient and we're going into the collection chamber, which is collecting whatever it needs to collect. If it's blood, that's here in red, then it's collecting that blood, that 200 milliliters in the first hour. If it's air, that air is going to come in here. Eventually, it's going to find its way into the water seal chamber. The objective of the water seal is to block air that's coming in and only let the air that we were suctioning leave. We can't have any more air coming in. So it acts as a seal, and the key term here is titling. Whenever the patient inhales and exhales, the key word they want you to know is gentle titling. That's okay. The water will move with inhale and exhale. That's normal. There should not be bubbling. There should not be continuous bubbling in the water seal chamber. Next, the O2 or the air that if it was a pneumothorax, especially, or if it wasn't, the suction control is those air bubbles, that continuous bubbling. Key memory thing here. The control is very similar to continuous. In suction control, you will be seeing continuous air bubbles. I have seen questions about that. Suction control is where you see continuous bubbles because we're pulling out those air bubbles out. They're leaving. That's why it's continuously bubbling. This is what it looks like in real life. I've never had the opportunity to actually see one, but...
Really?
Yeah, no, I haven't. I've seen a lot, but I've never seen that. Okay, so what's some fucking problems with the chest tube? Well, if it's knocked over, ask to take it to deep... Sorry. Ask the patient to take a deep breath, and then you set it back up. No big issue. If you call the doctor's going to think you're stupid. So what if it breaks? Number 1, you clamp the tube. Number 2, you cut the tube away. Number 3, you submerge. And number 4, you unclamp. For number 1, the clamping of the tube prevents the air from getting into the chest. So we don't want outside air pushing into that chest because it's just going to collapse that lung. It's just going to run through that fucking lung like a football player on the field. It's, when we clamp the tube, it's going to mimic the water seal that we had before. So we're not letting anything get into the chest. We're going to clamp it. Then we're going to cut the excess part of the tube away. Then we're going to stick it into sterile water. This sterile water is, again, mimicking the water seal, so no outside air is allowed into the chest, because then we'd kill our patient. And then we're going to unclamp the tube where it was initially clamped. All of this has to be done within 15 seconds. So again, clamp, cut away the tube, submerge the tube in sterile water, and unclamp it. If you were asked what was the best thing you could do for your patient, if you were held at fucking gunpoint and the board of nursing with their gun in hand told you, you have one thing you can choose to help save your patient, what would it be? And the one thing you would choose, the most influential thing you could do, would be to submerge that tube in sterile water. There we go, all under 15 seconds. Yeah, there we go. First versus best action. Here I explained it. The first action is to clamp. When you're being asked a first versus best question for first, you're being asked to list the steps in a sequence. So imagine a Jenga tower. Which block or step, when you pull it out, would make all the other blocks tumble down or would make the other steps impossible to complete correctly? When you're asked the best action is to submerge in sterile water. It recreates the seal and prevents air coming in. Again, if it's best action, imagine the board of nursing is holding you at gunpoint and you can only do one thing to help save, prevent harm, educate your patient. What would you choose? The water seal, the question. The water seal chamber of a chest tube in a patient with pneumothorax/hemothorax breaks. What is the first course of action for the nurse? Knock, do you know the answer?
Climbing.
Yes. The first action is clamping. There we go. Okay. The water seal chamber of a chest tube with a pneumothorax breaks. What is the best or priority action of the nurse?
Submerge.
There we go. Because I held her at gunpoint and forced her to tell me that. If the chest tube gets pulled out, every time I think about this, I think about the time that Miss White held one in her hands and swung it around the whole damn classroom. Never forget that, and that's why I'm afraid of ICU. So if a chest tube gets pulled out, the first thing you're going to do is take your hand and cover the opening. That is the first step. The second step, or I reduced it into 2 steps. The first thing you're going to do is cover the fucking hole. Cover the opening. And then next you're going to take a Vaseline gauze and tape 3 sides of it. The reason we don't tape all 4 sides is because it's going to trap air in and the lung is going to collapse. We're pushing down on the lung. So allowing one side to be open, so only 3 sides, allows some air to escape from the body outside. Okay, we don't want to lock the fucking air in either. So hand on the hole, Vaseline gauze, tape. The most important part here is the Vaseline gauze and taping it on 3 sides specifically. The first move is covering it with your hand. Bubbling, we just mentioned this. Ask yourself, 1, where is it bubbling? And 2, when is it bubbling? Bubbling in the water seal chamber, if it's intermittent, it's good. Document it. Remember, the water seal prevents outside air from coming in. There is no need for it to be bubbling that much. Only rising and falling with inhale and exhale. That's called tidling. If it is continuous, it is bad and indicates a break or leak in the system. Your action as the nurse is to find it and tape it. Bubbling in the suction control chamber. If it is intermittent, the suction pressure is too low. Your action as a nurse is to increase it at the wall until it is continuous. Remember, continuous is good in the suction control chamber. Control for continuous bubbling. That's my trick. The control chamber is where air is suctioned out and leaves the system as little air bubbles. The lack of air bubbles indicates that there's a lack of air leaving the system. And some analogies that he said are a straight catheter is to a Foley catheter, a thoracentesis to a chest tube. I don't know. Okay, I guess he was talking about chest tubes or thoracentesis. Whatever. The rules for clamping tubes. Do not clamp a tube for more than 15 seconds. That whole process of clamp, cut, submerge, and unclamp has to be done in less than 15 seconds or 15 or less. When you use clamps, you are using 2 clamps that have a rubber tooth so that they don't puncture the tubing. So when the water seal breaks, no more than 15 seconds to clamp, cut, submerge, and then unclamp. And that is